Hey y'all, Dr. G here. In this video we are going to explore a topic that I know you've seen in your high school algebra courses or your college algebra class. It's one that for some reason a lot of chemistry students still struggle with. So I want to make sure that I cover it and give you an opportunity to explore it a little bit in your upcoming assignments. Okay? And that's the idea of FOIL, right? So if we have an expression like x plus 2 times x plus 2, this is actually a really common expression that we see when we start dealing with some chemical applications. Okay, so you need to be able to work with it. So hopefully you remember the FOIL acronym. First, outside, inside, last. So the idea here is we are going to multiply the first numbers together. So in this case it's x and x. So here we have x times x, or x squared. Our insides, that's 2 and x. So we're going to do plus 2 times x, or 2x. The outsides are again 2 and x. So we have plus another 2x, and then the lasts. So that's going to be our two values of 2 here. First, outside, inside, and last is a 4. So we have multiplied these two factors together, x plus 2 and x plus 2, and we end up with an expression that has 4 terms. Okay, and it's going to be pretty common that you'll be able to simplify these 4 terms into 3 terms. And in fact, in basically every real application we see in this class and that you see in your subsequent chemistry courses, you'll probably be able to simplify this to a 3-term expression, a quadratic expression. So we recognize here that both 2x and 2x have the same factor of x in it, so we can combine them. This ends up being x squared plus 2 plus 4x. 2x plus 2x is 4x plus 4. Okay? So x plus 2 times x plus 2 is equal to x squared plus 4x plus 4. And this is a much more useful form than this. Let's see another one. Let's use a little bit bigger numbers. Here we have x plus 10 times 2x plus 5. Okay? It doesn't matter that we have bigger numbers. It doesn't matter that we have a factor of 2 in front of x. We still take the same approach. FOIL. Our first, our x and our 2x. So this is 2x times x, so 2x squared. Our outsides, x and 5. So plus 5x. Insides, 10 and 2x. So 10 times 2x is 20x. And now our last is 10 and 5, plus 50. Just like we saw up here, we can simplify this expression by combining together the 5x and the 20x to give us 2x squared plus 25x plus 50. Okay? Different numbers, a little bit bigger numbers, but exactly the same approach. FOIL. Let's go ahead and look at one more. So we'll do 2x plus 10 and let's say x plus 4. Make this a little more clear here. 2x plus 10 and x plus 4. Our FOIL, our first, 2x and x, 2x squared. Our insides, 10 and x, so plus 10x. Our outsides, 2x and 4, so 2x times 4 is 8x. And last is 10 and 4, so plus 40. Okay? Just like we saw previously, we can simplify these by combining 10x and 8x. So we get 2x squared plus 18x plus 40. Okay, and as it turns out, we can actually simplify this one step further if we want to. Okay, what I hope that you notice here is that each of these integers are even numbers. So they're all divisible by 2. So we can actually remove a factor of 2 from each of these to give us x squared plus 9x plus 20. So this is a simplified version of this. And just so you know, the reason this works out is because when we set up expressions like this, what we're not writing is that these are equal to 0. So this equals to 0. So as we factor out a 2 from each of these, we can divide both sides by 2, and 0 divided by 2 is still 0. So this is still equal to 0. If that algebra is beyond what you're interested in thinking about, that's okay. I just wanted to explain it to those of you who are interested in why this works. Okay, so I hope you're comfortable using this FOIL approach, because you're going to see it in a couple of different applications in this class, and certainly you're going to see it in some applications in general chemistry. Okay, so in the next video, I want to take these equations one step further using the all-famous quadratic equation to solve for exactly what values x can be in these expressions.